All right, welcome to The Explainer. Today we're going to explore the incredible, invisible systems that keep our bodies from falling apart. We'll look at how they work and, more importantly, what happens when they get pushed to their absolute limit. So let's kick things off with a story. Picture this: the 2004 Athens Olympics. It is brutally hot, it's humid. Paula Radcliffe, a world record holder and the hands-down favorite to win the marathon, is out in front. But then, something goes terribly wrong. Her body's internal systems, pushed way beyond their limits by that intense heat, just start to fail. So what exactly happened to her? Well, it's a condition called heat stroke. And it's exactly what it sounds like. It's when your core temperature skyrockets so high that your body's most essential machinery starts to literally break down. And this isn't just a risk for elite athletes, It's a real danger for soldiers, for firefighters, really for anyone who has to be physically active when it's hot out. So that begs the question, what is this amazing, invisible system that's working around the clock to stop this from happening to us every single day? Well, to get that, we need to take a look at the world inside our bodies. You see, our cells aren't just living in a dry world. They're all floating in this kind of internal sea of fluid. This is our internal environment. A better way to think about it is like a perfectly serviced private moat for every single one of your cells. It's constantly delivering all the good stuff they need and carrying away all the garbage. And this whole process, this constant job of keeping that internal sea perfectly stable, not too hot, not too cold, with just the right mix of chemicals, that's what we call homeostasis. It's really the unsung hero of our physiology, always working in the background, keeping the whole show running. But how does the body actually pull this off? How does it know when things are getting a little out of whack? And more importantly, how does it fix the problem? Okay, let's dive into this with a really simple analogy that I think makes it all click. A thermostat, the one in your house. You set it to the temperature you want, and it just works, right? It keeps the house right there, whether it's blazing hot or freezing cold outside. Well, this system runs on something called negative feedback. Now, I know the name sounds, negative, but it's actually the absolute key to stability. It just means that whenever the system senses a change, say it's getting too hot, it triggers a response that counteracts or negates that change to get everything back to where it should be. And what's so cool is just how closely our biology maps onto that simple machine. So your home's set point might be, say, 70 degrees. Your body's is right around 98.6. Your house has a thermometer, your body has nerve endings, and a part of your brain called the hypothalamus that act as sensors. If you get too cold, instead of a furnace kicking on, your muscles start to shiver to create heat. And if you get too hot, forget the AC, your glands start producing sweat, which cools you down as it evaporates. It's the same logic, just biological. So why is this so important? Why all this fuss about staying at that perfect 98.6 degrees set point? Well, it all comes down to just how ridiculously sensitive our body's chemistry is to temperature. We can actually measure this with something called a Q10 value. Let's just imagine, for a second, a typical chemical reaction happening in your body at a pretty cool 20 degrees Celsius. That's about 68 Fahrenheit. We'll call this our starting point, our baseline rate of 1x. Okay, now watch this. If we just bump the temperature up by 10 degrees Celsius to 30 degrees, that reaction doesn't just speed up a little bit. Nope, it doubles. And if we raise it another 10 degrees, up to a dangerous 40 degrees Celsius, that's 104 Fahrenheit heat stroke territory, the rate is now 4 times faster than where we started. So here's the crucial takeaway. Your body has thousands of different chemical reactions happening all at once, and they're all interconnected. If even a small temperature shift can cause some reactions to double or quadruple in speed while others don't, your entire metabolic network gets thrown into absolute chaos. That's why homeostasis isn't just a nice feature, it's essential for survival. Okay, so our bodies are working hard to keep everything stable. But in the animal kingdom, some animals have evolved to basically hack their own homeostasis, pushing their internal thermostats to the absolute limit. Just look at a ground squirrel getting ready for winter. It doesn't just get cold by accident. Its brain, that hypothalamus again, intentionally cranks its own thermostat way, way down. It puts itself into a state of regulated hypothermia, dropping its body temperature to near freezing, which slashes its energy needs and lets it survive for months with no food. It's incredible. Now, let's head out of the forest and dive into the ocean. Most fish are what we call ectotherms. Basically, that means their internal temperature is pretty much whatever the water around them is. They're kind of at the mercy of their environment. But hold on, that creates a puzzle, doesn't it? If that's true, how can these powerful, super fast predators like a great white shark or a bluefin tuna be so good at what they do in frigid, energy-sucking waters? Well, they use this absolutely brilliant biological plumbing trick. It's called countercurrent heat exchange. They have this special setup where their blood vessels are arranged so the warm blood that's leaving their powerful swimming muscles flows right next to the ice-cold blood coming in from the gills. The heat literally jumps from the warm blood to the cold blood, trapping it inside the muscles right where they need it most. This can keep their core up to 15 degrees Celsius warmer than the water around them. Okay, this is all fascinating stuff, but what can we as humans take away from all this? How can we actually apply these principles to our own lives? Well, it turns out we have our own little biological hack. While our ancient ancestors were covered in fur, we inherited their specialized heat portals. What are those? They're the areas of non-hairy skin, so the palms of your hands, the soles of your feet, and your face. And they have these unique blood vessels that are designed to act like radiators, perfect for dumping extra heat really fast. And this isn't just a theory. You can see how powerful this is in practice. In one amazing study, scientists had athletes do bench presses until they just couldn't do anymore. Then, between sets, one group rested normally, while the other group simply put the palm of one hand on a cooling device. And the results were astounding. The cooling group was able to perform way more reps. By pulling heat out of that one little spot, they were able to reduce muscle fatigue and dramatically boost their physical capacity. So when you step back and look at the big picture, you realize our bodies are in this constant, dynamic state of self-regulation. And really, just appreciating the invisible work of homeostasis is the very first step to understanding the limits and the incredible potential of our own bodies. So I'll leave you with this final thought. Homeostasis is the silent engineer that's keeping you alive and running every single second of every day. From improving your athletic performance to just feeling better day to day, how could understanding this system a little better help you master your own internal environment?